Alright, so all we have left to do before we do the case air check is assemble and install the intermediate band servo. We're going to put this little filter screen in its location right there, and then we'll go ahead and install the check balls, which are still on the bench. Okay, so a Teflon sealing ring comes in the kit for the servo assembly. So all you really have to do is just carefully work it in. Okay. You don't need to resize these, or there's no special sizing tool or anything like that. All you really need to do is just work it around and then get it seated in the groove and more or less resize it by hand. So this is a very simple assembly. You're going to have a little horseshoe retainer. Okay, that's going to retain this pin. Then you're going to have your spring seat. Okay, that'll go over top. And then you're going to have your spring itself. So let me lube the board. And then we'll lubricate the new sealing ring. Okay, this is going to be for your engine braking in manual second. Okay, there's no real band clearance spec for this. I mean, all you're really going to do is, when we do the air check, we'll put air in the circuit and validate that this thing is applying like it should. Okay, the only thing you have to worry about here is having the sealing ring getting hung up on the lip. Okay. And then this little filter is going to go in this location right here. So I'm just using this, I don't even know what the hell it is, to seat it. And that's it. Alright, let me go ahead and put the check balls in. I'll do like a bird's eye view for you. You can see where all the check balls go, and then from there we'll put the plate the case gasket on and the test plate so that we can perform an air check. So hopefully there's no issues with the air check. Otherwise we'll have to go back into the case and investigate them. Before I forget, let me go ahead and torque our overdrive feed bolt. So 144 inch-pounds on this bolt, so 12 foot-pounds basically. Torque's 40. And that's it. Doesn't need any more than that. Alright, so here are all the check ball locations. More than likely you're not going to have a check ball here, and I believe that was installed only on a few different, specific submodels of 480E over the years, but the rest of them that you see here, there's going to be 8 total are in these locations. Okay. Now, if you don't have it and you plan on building 480Es, in some frequency, you may consider purchasing the ATSG's check ball book. Okay, this is for domestic, and among other things, it will have for you a diagram of 480E check ball locations. Now, the way they have it, this is the front of the case, this is the rear. So I'm showing it to you kind of sideways, but these are all of the different check ball locations and their functions. So if you don't have it, it's a worthwhile investment. I think these books are 30 bucks a piece, and you can get them anywhere online, or usually transport suppliers will have them too. So, okay, the case gasket. This is the separator plate to case. All the kits that are sold today, they're all going to have the first design gasket, and that features these cutouts here for the feed pipe and the blowhole location. All right, that obviously doesn't exist in the center lube 97 and up units, but the The gasket itself will work with any year 4 LADE, so they've eliminated the second design separator plate to case gasket from the kits. So if you're working on a late unit and you don't see like a corresponding second design case gasket, don't worry about it. They want you to use the first design because that's all they're going to give you. All right, let me bolt the test plate on and then we'll go through the process. I'm not anticipating any issues, but you never know. And then from there, we'll do our parking and selector linkage and valve body, wiring harness, and all that good stuff, and that'll basically be it. All right, plate's been bolted. If you're wondering where to get these plates, they're made by Trans Tools. I think there's actually a couple of different manufacturers, maybe like, I don't know, anywhere from 2 to 4 or so, but they all look the same, and you can buy them on eBay, on Amazon, some transmission part suppliers, either on the web or, you know, brick and mortar may have them as well. So if you're doing transmissions in any kind of volume at all, I would strongly recommend you buy one of these plates for the units that you work on frequently. They could save you a lot of rework, a lot of hassle, and, you know, frustration. Every once in a while you'll install something into the case and you'll, you know, get a sealing ring snagged and it'll break, or, you know, it'll bend or whatever, and that'll show up when you go to do the air check. And you may test them fine on the bench, you know, with the pump and the drums or whatever the case may be, center support and direct drum. But when you go to put everything in the case, before you bolt the valve body on, it is always recommended that you do a comprehensive case air check. And for transmissions that have what I call a closed case design, meaning there's, you know, worm tracks in the belly, then, you know, it's not exposed like, say, a Ford C6 or 727 or something like that, these are great to have. So some transmissions you don't need them, like 40100s, you don't need a test plate because you can get to every single apply circuit just via the case belly itself, but others it's just a little more difficult, if not impossible. Okay, so here's forward clutch. This is going to be your overdrive clutch, your coast clutch, and then here's your manual second band, and then this is going to be direct, intermediate, and high reverse. And then here's your low and reverse band release, but this is, you know, where we actually test it. And then they have this as the apply, but you know, I like to test it here. It's a little bit more robust. Anyway, we'll just start from the forward and work our way to the back. Okay, hear that? That's nice, firm apply and release. Overdrive. Okay, same deal. Okay, and the other thing is you're hearing trapped air whooshing out of the circuit. So when you put air into it, okay, it takes like a split second for the air to actually escape after you've released your finger off the trigger. So that's always a good sign. Okay, that's your overrun. You hear how hard that applied initially. That's because that clutch has almost 90 thousandths of clearance in it. So remember when I was telling you, much earlier in the video, now if you don't remember, that's okay. It was a long time ago, but the more clearance you have in a pack, the firmer it's going to feel when that clutch comes on, when you make that shift. Okay, manual second band. Okay, very good apply. Low reverse, do that first. All right, hear all that air escaping. There's nothing but gasket between all 4 of these ports here in the plate. Okay, there's not an actual hole here in the gasket. So even with the gasket in the way of the applied element and your air source, it is still applying that clutch really, really nicely. Or in the case of the band, it's applying the band really nicely. Here's direct. Okay, we'll do high reverse. May have to plug the direct feed because air will come out of here. Okay, hear that air whooshing out. And then intermediate. Okay, hear all that trapped air whooshing out? That means you have really, really good sealing integrity in that clutch. or that apply circuit, and that's what you want. Okay, you don't want anything giving you a whole bunch of hissing or no apply. If that happens, then at least it's happening now when the transmission's on the bench or on the stand and not in the customer's car or in your car or whomever's car, truck, or SUV or whatever that your transmission's bound for. So, all right, we're gonna remove this test plate, then we're gonna start putting everything back onto the belly of the case. We'll start with the linkage here, and then we'll move to the valve body, the harness, and then filter, gasket, and pan, and then we'll bolt the extension housing on. And then from there, I'm going to just simply get this thing on the bench. I'm going to install the speed sensors off camera. I mean, it's 2 8mm bolts, and you lube up the O-rings. That's pretty much it. And same with the external linkage. So if you haven't done so already, you may want to grab a picture that you should have taken, or at least it would have been a good idea to take, of all of the wiring arrangements. In other words, where you have the loom retainers and or keepers for your wiring harness, because these can kind of be a little complex if you're not used to dealing with them. So anyway, we'll get to that, and then we'll wrap up. All right, now we're going to go ahead and install the shift and parking linkage. So again, a very straightforward process. So we'll start with our selector shaft, and what I'm doing is lubing it up. Okay, goes in this direction. Just get it in there kind of part way. And then what you're going to need to do is set up your parking rod assembly and kind of pair it with your rooster comb. So for the rooster comb, you're going to have the engagement stud for the manual valve facing the transmission case, facing that way. And then you're going to have your comb situated between the two engagement tabs here on the parking rod. All right, and then for your spring, I've already installed it. But here, let me get this out of the way real quick, and I'll show you just how it goes. It's, again, very simple. So just loop it here on your stud, and then the hook faces to the rear of the case. All right, just like that, pretty simple. All right, now we're going to install the castellated nut. So just get that to seat, thread it on. And then you just have to get the comb on the two flats on your selector shaft. Okay, then the last thing you're going to do is put the little nail near the retainer and seat that. Okay. You don't have to get stupid with it. You just want to make sure it's seated and it's in there. I mean, you'll feel it travel a little bit, and then it'll come to a stop. I mean, it's hard to tell on camera, obviously, but you'll know it when you feel it. So 15 millimeters on this nut. And you want to crank on this really good. You don't want that nut coming loose. Okay, you can see the little wear pattern there on the case where the comb bottoms out. That's how you know you're lined up. All right. Lastly, you have your parking pole assembly guide retainer or guide bracket, guide plate. Okay, it's going to go just like this. So looks like an easy chair. The easy chair will be oriented upright, just like any other chair. Two 13mm bolts. And there is a torque spec for these. In fact, let me go get it. So it's 18 foot-pounds. So we'll go ahead and we'll torque to 18 foot-pounds. You can also just crank on it using the German method, good and tight. That also works. But we'll be precise and torque it. Okay, now we'll go ahead and do the valve body. In late model units, there is a couple of bolts that you're going to have to, actually I think there's one bolt in the rear that you're going to have to actually bolt it down and torque it before you install your feed pipe that comes from the rear of the valve body into the case, you know, back in here. Okay, these pipes go in the same place in the back, they're just simply different dimension. And that's owing to the design change for the rear gear train's lube circuitry. Might be a good idea to put like some assembly lube on that case gasket so that it doesn't move around. Okay, you want to have the manual valve out and in position so it can drop right on in and link up with the stud on the rooster cone. And I'm just going to drop in a couple of bolts to make sure that I don't come out of mesh with, or out of alignment rather, with the gasket on the case. So when we did the valve body video, we showed you, how to make sure that all of the bolt holes are through and through between the casting and the separator plate using the Z-bolt locations. So here all we're doing is just simply making sure that the case gasket isn't getting, pushed aside or out of alignment or whatever. Alright, with the valve body positioned, I'm going to go ahead and open up the packaging for the harness and get that installed. So I'm just lubing up the green O-ring for the case connector. Fortunately, these have a real bad problem with the factory case connectors, in the original harnesses, leaking through the connector itself, and then when that happens, you'll have issues with the electronic portion, or electronic parts I should say, communicating with the PCM, so you might end up in limp mode as a result. So limp mode in these transmissions is second gear, and that's it as far as your forward shift pattern. So this may take some persuading, And maybe just get a little bit more lube down there on that board. So it's a good example of what happens when you don't use enough lube. Lather up the O-ring again. And then this flat edge here, okay, the squared off portion faces up with the case oriented with the belly facing up. Okay, if you were doing this in the transmission, in the vehicle, this flat side here would be facing up. Or I should say facing down. Okay, you can start connecting everything now so that you have a good idea of where your routing, you know, your little retainers need to go. Alright, just whatever you do, don't force anything. If it doesn't seem right, doesn't feel right, then it's probably not right. Okay, this red connector is for the pressure switch manifold. And then these two are different. Okay, this is a roster harness. This harness will work on all years 1991 through 2003. 2004 and up, they changed the EPC connector to a connector that looks like this. So that is no longer, you know, that harness was no longer in use. So 4 and up have a different connector there. The continuity value or resistance did not change at all. It was just a change in the connector design. Okay, not a whole lot of changes to the 480E electronically after that. You know, after 1993, 93 they changed this harness. The 91, 92 harness and connectors are a little bit different, and then in 94 they, you know, starting in 94 they did away with that torque compensator valve in the accumulator body assembly. Alright, so now I get my feed pipe and position that. Okay, I'm not going to really install it per se. Actually, I guess I can. Okay, so this location right here, these two bolts, that's going to be for your dipstick stop. And you're going to have a loom there on top of the stop. So and make sure that they thread in. Okay, and then you can, once these are bolted down, we'll go ahead and set up our loom. Okay, so we have another loom location here. It's going to face like this with the little keeper in this square cutout on the valve body. Okay, once I get all these keepers in, then I'll just put the rest of the bolts in and we'll zip them down. Okay, here's that short bolt. This is the only short bolt on this valve body. All the rest of them are long. The 8mm bolts are for the pressure switch manifold. And then it goes like this. So you see how it's kind of upturned? Okay, that's how it's going to go. And if there's any doubt, you can see the wear pattern there where the bolt was installed initially at the factory. Alright, the next bolt with a keeper of some sort on it is going to be located here. And that's going to be your rear hold down for your pipe. And then there's one more keeper in the area of the pressure switch manifold. And that's going to be right here, right at the rear of the valve body. It's going to face this general direction toward the servo cover. It's bound up a little, so. Alright, that's in there. Okay, rest of the bolts will install except for the 2 bolts for the detent roller. And then we'll install the pressure switch manifold assembly and its bolts last. Alright, so here's going to be your detent roller. It's going to be going into one of the Z-bolt locations. And our PSM. And I'll leave that bolt out. I'll plug the PSM in, and I'll put that bolt back in there. So all these bolts get 97 inch-pounds. I mean, you could do 95 to 100. I've done 100 on these, no issues. But we're going to use 97 for the purposes of this video because that's what the spec calls for. I'm going to get one more bolt. And I don't want this bolt hiding from me. Alright, we'll zip down all the 10mm bolts first. So I'm going to put a little bit of downward pressure on the valve body because, again, I don't want the bolts to seat the assembly. I'd rather not risk stripping out, although, I mean, just to be honest, it's not likely that that would happen, at least with these bolts, but you can't be too careful. No particular torque sequence, at least none that I've seen, but generally speaking, what I'll do is I'll go and I'll torque this whole row of bolts first, and then I'll move to this row, including the PSM, then move here, and then do this whole row, and then, you know, finish out with the perimeter bolts. All right, let me get my, let's see, these aren't zipped down. Check any more 10mm bolts. Looking proud, I don't see any. Alright, plug in the pressure switch manifold. If this thing goes bad, there is a possibility you won't be able to start your car because it works with the manual lever position sensor that gets bolted here on the outside of the case for everything 95 and up to inform that you are in fact in either park or neutral, because if it doesn't see that, you know, it can't confirm that via, I believe it's channel N, then you will have a no crank, no start condition. I have a separate video on that issue for these N4L60Es. Manual lever position sensor is usually the cause. That will go bad first before this, in most cases, unless there's massive overheating, then it could short this out, or otherwise, you know, render it inoperable. But you know, for the most part, your PSM, if it goes bad, you'll get a code P1810, I believe. P1860 is the PWM solenoid. Okay, so I'm just checking, making sure that my looms are kind of where they need to be routing wise. This is your trans temperature sensor. So you can test all this stuff via the case connector itself without having to take the pan off. I have a video on that that'll show you how. It's a fairly straightforward process. You just need a DVOM meter that's capable of reading continuity and voltage. You can test the speed sensors too. So, all right, let me kind of route this. I'll make sure that's done. Actually, that I'm gonna have to leave exposed. This just tucks under here. Okay, I can get to that bolt, I can get to this bolt. This kind of just gets tucked a little bit out of the way under here like this. This will collapse. So now we're in a position to torque everything up. All right, now we're gonna torque everything up, 97 inch-pounds. So as I mentioned, I'm going to go down here at the center row, and then this way, and then this way, and then just kind of spread out from there. So again, no particular torque sequence. This is just the way I like to do it. So I'm just getting snug. And again, this is also personal preference. You can go right to torque if you want. as long as you're careful, you're not being a gorilla about it, you shouldn't hurt anything. Okay, so that's this row here. I'm gonna do this bolt and that other 10mm bolt. And the one next to it. Alright, to clean up this wire loom. I'm going to switch out to the 8mm and do all the 8mm bolts here on the pressure switch manifold. Alright, so now what I'm going to do is I'm just going to check every single one of these bolts. I'm going to go row by row. Alright, there's going to be some that will compress a little bit further before you get to torque. Just because there's, you know, pockets of gasket that are not fully seated or not fully compressed. Plus it helps to check so that you don't accidentally miss any. Because I have in the past. There's one under there, nope. Okay, just like there. Okay, I didn't hit that one. All right. So that is everything as far as valve body to case bolts. So we just have filter and pan gasket, etc. And then we'll move to the extension housing. All right, and whatever, depending on whatever kit you buy, some of the kits will have these, bonded kind of steel inserted rubberized gaskets, which are completely reusable. That is the kind of gasket I always use on 480Es. I think the Transtech kits will come with them, but the ones from Transtar will not. They'll come with just a regular composite type gasket, which is fine. It's not the end of the world to use that kind of gasket, but it is my preference to use one of these kinds of gaskets. Okay, I gotta go fishing for a magnet because I don't have a magnet for the pan, so let me do that and then we'll be back and then we'll deal with the pan, get that bolted on. Alright, was able to locate a magnet for the pan. Not entirely sure if that was the magnet that actually came out of there or not. I think it was, but not 100%. Alright, let me straighten out this wiring loom. And then I'm not going to film the entire, pan bolt torque sequence. It's 97 inch-pounds. I generally will start along here on the long axis and then work my way from the interior outward, and then likewise for the ends, and that's basically it. It's not rocket science. 97 inch-pounds. Any torque from like 95 to about 105 for most transmissions is going to work for you. That'll seal the pan up, so you don't leak or have any problems. For some older transmissions, you're going to need around 125 to 150 inch-pounds. But most of the newish ones are in that 90 to 110 inch-pound range, at least for GM. I don't think Ford and Dodge are too much different than that. If you torque everything to spec with it, when it comes to the pan, and you're still leaking, and you're using a factory sheet metal pan, then chances are the pan itself is warped and it'll never seal. Too many guys use RTV on these things, and that causes nothing but problems. RTV eventually will break off on the inside because it'll kind of spread. As you torque the pan down, some of it will kind of spread inwards, and as a result, you'll have all kind of issues. All right, so wiring loom seems to be in good shape. Just making a quick check of all the connections, making sure that they are in fact connected. Everything appears to be as it should be. Alright, a lot of times what I will do for every transmission I build, because I'm always paranoid about leaving a connector unplugged or something, I'll just take a picture of everything. Filter in, sometimes not. As long as I can see everything, I'll take it with the filter in, but if not, I will take it before I put the filter on. And that at least will help me sleep at night, knowing I didn't forget to put a connector in place, or I left something, undone. Let me gather up the rest of the pan bolts. There's 17 of them total, 10 millimeter. I said, 97 inch-pounds. So that's what we'll do. The 97 and up transmissions have a different pan. These pans are not interchangeable as far as I know. At least I've never tried to interchange the pans between the different vintages, or I should say different generations of transmission. So B&M makes really nice deep pans if you have enough ground clearance, which is going to be folks with trucks. Or I guess you could put one in a car too if it's got enough clearance. Adds like an additional 3 to 3.5 quarts of total capacity, and that'll help keep the trans cool. I mean, heat is one of the 2 biggest enemies of transmissions and engines in general, the other being excessive RPM. So once this is on, I'll install the extension housing, bolt-on yoke. I gotta look up the torque spec for that thing. Alright, if it doesn't want to go down voluntarily with that low power impact, I'll just use a socket and a ratchet. And another thing about these is because they have steel inserts for your bowl locations, you're pretty much going to be at torque once you get there initially, unlike a composite gasket, which, you know, that will compress, and typically you got to go around the pan like 2 to 3 times to get to true full torque. Because you go around twice and, you know, you'll still be taking up some slack, but you go around 3 times, you should have all of the compression taken out of it and be at true torque. If you don't do that, there's a minor chance it might leak, but it's minor. I built a bunch of these where I've never done that, or I didn't do it, and it didn't leak. Okay, I may have lied when I told you I wasn't going to film this whole thing. Maybe I will, you know, as far as pan installation. As far as the entire video series, I mean, it's approaching 5 hours long, so I'm gonna have to figure out how I want to divvy it up. You know, as I'm filming this, of course, you will have already known how I've decided to do that. Oops. Alright, so as you've seen throughout this video, there really wasn't a whole lot of special tools I needed beyond just what I will call the usual, meaning tools that you would need no matter what transmission you're working on. So bushing drivers, dial indicators, torque wrenches, things like that, you know, lip seal tools. So, and then of course your ratchets, sockets, hammers, punches, all stuff that you probably already have. So I may do a separate video series on transmission building, you know, tools of the trade or something like that. So if folks are curious, and for those that have kind of literally no idea when it comes to the tooling, maybe I'll do a video that walks folks through all the different tools that they're going to need, and, you know, priority and all that stuff. Okay, I'm just working with the extension housing now, lubing up the bushing and the rear seal. So you're going to want to have your square cut seal positioned. Okay, this thing, can't remember now. I mean, it was only like a week ago, but I literally can't remember if this came in with a transmission mount or not. But the transmission mounts, I always recommend folks just replace them as just, you know, part of the whole overhaul, overhaul process. There's no reason to reuse an old transmission mount. So unless you've replaced yours recently, like, you know, it was replaced, I would say no more than about 5,000 miles ago, I would simply replace it. Or at least you do a really thorough inspection of it, make sure it's not cracked, because a lot of them, as they age, they'll have like little cracks that maybe aren't as readily visible at a glance, but once you really start looking at it, they start to reveal themselves. Alright, typically extension housings like this will get between 30 and 40 foot-pounds. So let's consult the manual and see what we should be doing here. The extension housing to case screw is 25 foot-pounds. So that's what we will dial up, 25 foot-pounds. 15 millimeter. Overall, this transmission was in excellent shape. And I've seen some 4LEDs come in completely grenaded, like literally almost nothing from inside the case was reusable or salvageable. And that's kind of been the pattern, at least that I've seen. Maybe others that have done these by, the thousands have a different distribution, but from the ones that I've seen, they either come in mostly good shape, maybe one or at most two hard parts, including the forward drum. I mean, that's typical of what you might have to replace when it comes to hard parts in these units that are otherwise in good shape because of the sealing ring groove wear. This one was in real good shape. Some of them, they just come in like completely gouged out in that area. All right, now the bolt-on yoke. And so I have to look up what that torque spec is. But here's the yoke in question. And with these, you want to do a check. Make sure that there's no grooves in the sealing surface area. I mean, this is where you can see the bushing, and then here we have a little bit of a groove here. So I'm actually not going to bolt this on. That's going to go in here. So I'm actually not going to bolt that on. You know what? I just screwed up. I forgot that O-ring. forgot that O-ring. The O-ring that goes onto the output shaft that holds back trans oil. And I forgot to put it on there. Whoops. So it's going to be right here. So that's, I guess, one of the things that if you ever want to get into YouTubing and doing how-to videos on something like this, you know, transmission building or engine building or whatever, it's something that involves a lot of steps. There's a lot of different procedures that you have to follow, and you know, a high degree of complexity, relatively speaking. Your attention is going to be divided, and you'll be focusing to some extent on the task at hand, and then to another extent filming it. So that's the hazards. All right, let me put this extension housing back on, and then I'm going to leave that yoke off because I want to see if, you know, if my customer wants to have it replaced. And then I'm going to flip the case over. We'll put the speed sensors, the pressure port tap, and the cooling line fittings back in. And then I'll go ahead and summarize the build, and that'll be that. All right, at the home stretch. So we'll go ahead and lube up the O-rings on the 2 new speed sensors. It's always recommended you replace these along with all your other electrical or electronic components. However, if the older speed sensors, the ones that, you know, came off the unit, are in fact working, then keep them in the vehicle, because if you you know, if you have a problem with one of the new ones, you want to be able to just quickly pivot and stick one of the other ones in there, and you know, that'll help you kind of get through until you can put new ones or replace the bad one. I'll get this brackets on tight. I don't remember speed sensors being this loose on the brackets, but I mean, most of them are a little bit loose. But not as loose as that rear one. I may replace that. I mean, for the purposes of just filming and finalizing the video, you know, we'll roll with it for now. But and I just spent about 5 minutes off camera trying to monkey with it, trying to actually get it dislodged, and it won't come off. So these screws, or bolts rather, get 97 inch-pounds, as does the bolt for the pressure port tap, which is right here. I don't know if you can see that. It's literally right in behind the right in behind this part of the fixture. So that's 7/16. So 97 inch-pounds. And And then the selector shaft nut to linkage rod is going to get 18 foot-pounds. I believe that's what they get. $15mm nut. It's backwards. Alright, and then core line fittings, and then we'll summarize. So, for the core line fittings, I like to use RTV Ultra Black here, and they go on the other side, and they get 28 foot-pounds. And these use, I think, 11/16. Yep, 11/16. Alright, let me install these and then we'll be back to summarize. Alright, another 480E in the books. This one went relatively smooth. You know, there's a few things we had to deal with, you know, some minor curveballs thrown our way, but nothing that we couldn't handle. So, overall, I'm happy with the way, you know, all my clearances and my, you know, travels and plays, etc. turned out. The valve body tested, you know, a-okay. So the application for this is a 2500 C series truck, two-wheel drive obviously, and it's going to be used just for, you know, daily driving, occasional towing and hauling within the design engineering limits of the vehicle and the transmission. And the engine itself is stock, so you know, it's just a well cared for vehicle. GMT 400 series platform, you know, those are kind of getting discovered and getting more and more popular as the days go by. So he keeps this one in good shape. He's doing a whole bunch of work to it in addition to the transmission, so he wants to keep it on the road for a good long while. So anyway, here's kind of a numerical or empirical summary of everything we did and everything, you know, insofar as clearances and tolerances. So forward clutch, intermediate and direct, all within specification. Low reverse band, we had to do a little grinding to get it there, but you know, it's good to go. We don't measure the coast band, it's just, you know, we put it in and that's it. Just as long as it applies, it's good. And then for our rear gear, we were at 9,000s. Reaction output carrier was acceptable. It's not, again, one of those things you can't really measure per se. We didn't have to shim it. The input shaft to overdrive planet, that snap ring was 20 thou, and that gave us a net end play of 23 thou. I measured it a couple more times off camera, and I kept getting 22 and 23 thou, so I'm just going to, you know, just in keeping with the principles of conservatism, I'm going to report a result of 23 thousandths. All right, so for our pump cover, the pressure regulator valve in plugs, which tend to, you know, get worn a little bit if a unit's been going through a few times, that held 16 inches of lift, so that's pretty good. The control valve for the TCC was 20, and the TCC limit was 18, and then our boost valve inboard was 15, and outboard was 25. And I did measure, well, as you obviously, you know, you watched the video, I measured the factory boost valve and sleeve as well, and both inboard and outboard were giving me 10 inches of lift. So even at 10 inches, this transmission did not show any indications that there was, you know, excessive stress on the frictions, line pressure issues, or what have you. In a high performance scenario, if this was to be dropped into, you know, I don't know, a drag car or something, as it was before it was overhauled, you know, you may have seen some issues there with that boost valve. So the yoke is a little bit scored, so that's why it's not bolted to the output shaft. So I'm gonna show it to the customer, and you know, he can replace it or run with it. Torque converter, all new converter. I have a local converter reman company here. They do all my work. They do excellent work, so I don't expect any issues there. They do a whole bunch of transmission related machining as well, so it's very, very convenient and very nice to have that. So all right, if you made it this far into the video, congratulations, and thank you very much as always for watching. I really appreciate all your views, your engagement in the comments section, you know, any shares, any likes that you're willing to give me, and of course any cups of coffee that you're willing to purchase on my behalf as a token of appreciation. I greatly appreciate that. So until the next time, thank you so much for watching once again. Looking forward to seeing you on the next video. We'll be doing more 4L80E related videos and publishing more content to the channel. So in my opinion, these transmissions are the best that GM has ever produced, unless you count the Allisons as being, you know, when they were part of GM. But you know, I consider them to be a separate company. So I would say these 4L80Es, as far as just a combination of like you know, minimal corrections and updates you have to make, and the amount of power and punishment they could take just out of the box from the factory, in my mind, make them, I don't want to say unique, but like, you know, they stand out in the world of overdrive transmissions for light duty vehicles. So light duty meaning, I think the limit there is like 12,000 pounds gross vehicle weight. All right, thanks again. See you on the next one. Take care. Enjoy the rest of your day or evening.